repeating. So we'll just let people trickle in since I'm still a bit early. Okay. And by the way, for those of you who are starting to think about projects for your, or about final projects for class, if you're into video games and your video game has a vibrant modding community, like any of the Paradox games like Hearts of Iron, EU4, Stellaris, or Witcher 3 or Skyrim, if you want to try your hand at making a game mod, I'd be more than happy for that to be counted as final project, because game modding is a lot of fun. It's like a community taking ownership of a game that they all enjoy. It's a community taking ownership of the experience. So I'd be fully on board with you learning to write a mod for the video game of your choice. Another one that has been done in the past couple, that basically I get at least one person doing each semester, is a Discord bot, right? So like something you can ask on Discord that will perform certain commands. Similarly, a Twitter bot or any kind of bot, like one of those misspelling bots on Reddit, you know, any kind of bot is kind of fair game, so long as it's got an amusing or good purpose and not a malicious purpose, right? No malice here. We don't want to make the world a worse place. There's plenty of people who are doing that already. Yeah, there's a big war going on, and that's terrible. So, and also I should just mention, relevant for this class, is that I'd expect that to see a bit more malware, like ransomware, to be coming out, you know. So ransomware, for those of you who are not in the know, basically is a program that says, hey, we've encrypted your files. You want them back? Pay us Bitcoin. And that Bitcoin is A, expensive, B, hard to really get back once you send it off to somebody like that. But also it's been noted that like ransomware and stuff will sometimes check if you're running on if your Windows machine is running on a Russian version or Russian local language, because you know, you don't want to, you know, a lot of groups that do this are based in Russia, and you don't want to necessarily get the FSB to come knocking on your door when you're living in Russia. You might end up with an accidental sudden case of falling out of Windows disease. And speaking of dictatorships, we're going to be talking about Roman numerals today on the Ides of March, which is an interesting coincidence and totally not intentional. So as I was saying before, I've run the grader for pretty much everything on Runestone. I will be posting quiz 5 soon, and that will have a quite extensive due date on it. Quiz 4 is due the 20th. That covers files and file reading. Quiz 5 covers dictionaries. Quiz 6 will cover Monte Carlo approximations, and you'll have plenty of time to master each of those. Once we're done with the pig lab, by the way, there's not going to be any more big homeworks. You're just going to have everything's going to be part of the final project, and we'll get into that over the next coming weeks. There will also be chances for extra credit assignments. So I will give out a couple more assignments, but they're not required. You'll notice that there's going to be a bunch of assignments that are out of 0. Right? Meaning they're worth 0 points, but if you do them, they could be worth, you know, replacing a grade. So if you fell behind beginning in the semester, or you just really like the sound of bonus points, then that's a good way to go. All right, so let's go to, and yes, I still have to run the merger. I'm sorry I didn't do it this weekend. I know I said I did. I'm a big fat liar. I'm sorry. So we're going to do an exercise that I meant to do last week, but I wanted to give you more time to touch on dictionaries before we did that. So what we're going to be doing is if you go to Runestone and you scroll all the way down to the projects, we're going to be doing project 13, converting Roman numerals. Okay. Make sense? So we're going to do this one in class, do this one today. So this will be an in-class exercise, right? Just like anything else we've done, where I'm going to work on part of it and give you the chance to try to work on it too. I suppose I should share my screen to the Zoom. So there we go. So right, table of contents. You can also find it in Canvas under module 8, I believe, but let me go ahead and drop the link in the Zoom chat, as well as on the Discord channel. Discord. Yeah. And so now Roman numerals, right? For those of you who don't know, were the numbering system that was used in Rome. They're still used these days in like movie posters and stuff, like, you know, produced MC something, you know. They're honestly they're a pain. Arabic numerals are so much better, which are also kind of, I believe, like Indian in origin, because naming is weird. That's probably a gross oversimplification. But there's a reason we don't use these days. It's because while they look fancy, they're a pain. So this is a picture that is on the island of Gozo. It's an island, and the island is a small island that is a part of the country of Malta, right? So if we, Citadella located in Malta. So this, and he took this photo, and Malta, he points out, has been conquered by just about everyone at one point or another in history, including the Romans, who presumably gave us Roman numerals, an example of which we can see up here, which it says AD MDCCC IV. That's a Roman numeral over there. With but what is the problem here? And the author points out that, like, what kind of Roman numeral is MDCCCCIV? You're not supposed to have 4 of the same letter in a row. That's a rule for Roman numerals, because Roman numerals have rules, annoying rules. It breaks the rules. And what they're trying to say over here is a 1904, the year 1904. But how do you correctly represent them? So Roman numerals follow these 4 rules. So basically repetition is addition. So if you have I, that's 1. If you have 2 I's, that's 2. If you have 3 I's, that's 3. And only M, I, C, and M can be repeated, which are respectively, I is 1. Okay, I is 1, X is 10, C for century, remember C for century, that's 100. And M, the way to remember that, M is 1,000, and we can remember that for millennia, right? So I and X, you probably know already, but C for century, M for millennia, okay? Only those can be repeated. Then we have 3 other letters, V, L, and D. V is our 5, a halfway value. L is the halfway point between 10 and, like, quote unquote, halfway between 10 and 100. L is our 50 value. And D is 500. And I don't remember any of these. It's so, but only your base 10, your 10 bases are repeated. So only your so you're only, so if we're gonna write 8, we're gonna do this. If we want 13, we're gonna do this, which is 10, 1, 1, 1, but you're not ever gonna do this, which would be 5, 5, and 3. You just don't. It's just one of those rules. We also write numerals that decrease from values from left to right, just like we do in the current system we use. So for instance, if I wanted to write 57 like this, right? I'm writing from greater, right? The 50 is greater than the 7, goes from decreasing places. Similarly, 57 would be L, and then we need 7, which would be V, I. So 50 plus 5 plus 2, 57. Okay. So, and then finally, if we want a number that would take, so to write a number that would otherwise take repeating a number of 4 or more times uses the negation rule. Writing a smaller number to the left of a larger number causes the sign to flip to a negative. So MCM XIV is 1,000, 100 before 1,000, so 900, 10, and 1 before 5, that's a 4. So if you have a value that comes out of order, it's a subtraction. So this is 1914. So to write 1904, the proper way, that is, they're trying to do 1904. That would be M, and then we need not 4,000. We need 900. So 900 is 100 before 1,000. So we are going to do CM. Okay. And now we need 4, which is 1 before 5. Check me. And I'm correct. So for our first exercise, I would like you to take a couple minutes to familiarize yourself with Roman numerals by doing a conversion exercise. So basically match the correct Roman numerals to the correct Arabic numerals. You know, convert from an insane system to a sane system, please, so that we can work in the insane system for a bit. Thank God we don't use any insane systems of measurement and units anymore. And we're all on the metric system, though. Thank God for that. I'll give you a couple minutes to do that. All right, do people need more time? All right, now welcome to the mini lecture on sometimes tests only test how well you test at tests and not actually the content matter. So for instance, we can note that of these matching values, 2 end with 9, one end with 8, but only one of them ends with 0. So we can grab this one without really translating it because we know it doesn't end with a 5, a 3, or a 9. And that is 1400. And it is, it's M 100 before D, which is 500. All right. We also know that we also know MCM is from the previous answer is 9 from over here. That means MCM is 1900. So the MCMs must go over here. This MCM ends with 8, so it must be 1998 without even checking the rest of them, but it is M, which is 1000, CM, which is 900, and then 1 before, it's 10 before 100. So that's 90, and then VII 8. And then this one is the same thing, but with 9. And then MMDX, so MM, 2 M's, that's 2000, D is 500. So that has to be that one. And this one is MMCCC, so 2300 and change. Again, tests are tough to make that they can't be metagamed. All right, so we're going to start out by, now that we are all experts on converting from Roman to Arabic, we are going to write a program that does it for us because that was terrible. And the program we're going to write is going to basically do 4 steps. The first and the last are fairly trivial, which is ask the user to enter a Roman numeral and print out what they put in and the answer, right? Assuming we have the answer, that printing it out is trivial. So, right? So ask the user for a Roman numeral. Validate to make sure it follows the rules. So rules 1 through 3 aren't actually that bad to validate. You got rules 1 through 3 aren't really bad to validate to make sure that those are good. This one's a mild pain. You got to make sure that, to validate that this is in the right place, that you can only have I's before the V and not, or I before the X. I suppose you could have an I before the M. It's not necessarily forbidden by this rule. You could have IM, but I don't think that's correct. But that's fine. That this one really all we have to check here is make sure we don't have more than 4 of these, 3 of these 4. And then when we convert it, we just have to make sure that, if it's out of order, we account for that. So, and now let's see. So part 2, validate. Part 3, if the Roman numeral is valid, you convert it. Hint, you will probably want to start by using a dictionary to map each single Roman numeral character to the correct Arabic letter. And so that's how we'll start with this. Okay, we're going to create a dictionary that is going to create a map bit, and a dictionary here will act as a translator, kind of like a dictionary would, for like like a English to Latin dictionary would be able to work as a translator. Not a dictionary in the dictionary definition sense, although that does translate a word to its definition, but a dictionary in the sense that it translates like Google Translate. So here's our we can call this convert if we want to. We can name it what we want. We could call it D. I'm going to call it convert, or maybe we'll call it Roman to, let's call it RTA for Roman to Arabic, because I don't have autocomplete on this, so we probably should make it short. RTA is Roman to Arabic dictionary, and we'll just simply write that in, and we'll write that in a comment, because if I look at this next week, I'm going to be wondering, why in the world did I call it RTA? You know, and wondering what it is. So comments are for you in the future, who, because remember, the person who coded everything up last week was an utter mad person. They had no idea what they were doing, and obviously were of questionable sanity. Okay, so we'll create a dictionary, and what we're going to do is we're going to say, hey, I is equal to I is the key, 1 is the value. V. So right, this is basically saying, we're basically setting up the key and value pairs. I1, V5, and we can test this by saying print RTA of V, and that will give us 5, right? So 5, and then X is 10. And then what is it? D, what? Not C, it's D, it's L. L is 50. L is 50. C is 100. D is 500. And then M maps to 1,000, right? We're not putting an equal sign in this dictionary because we're not setting a variable equal to a value. We're assigning key value pairings, which are different, very different. So there we have a dictionary now. So validate the number to make sure it follows all the rules, okay? So we need to check that it follows all the rules. So repeating a number 3 times represents addition. Okay, yeah, we can repeat a number multiple times. Only I, X, C, M can be repeated. V, L, and D should not be. Okay, and 4, that mixes in with 4, that you can only repeat these numbers up to 3 times. If we go 4 times, that's too many. So and then finally, we have to write numbers that decrease. Well, that's not so much a rule as a rule for addition. So let's go ahead and make sure that def validate. It's really making sure that that we only have certain numbers. So validate Roman. Yeah, validate Roman, which will be a string. So what we need to do is we're going to go through we're going to go, let's go with repeatables. Now we can just simply hard code it. So for letter in, actually, so for letter in digit. So I, X, V, C, and M. So I'll let you finish this small portion of it. But basically, what I want you to do is take 2 minutes to figure out, to think, we want to ensure that I, X, C, and M appears at most 3 times. Each of those that appear at most 3 times in our Roman digit, okay? So take a couple minutes to do that. Don't overthink it. Those are a separate case. We could use the key, but we're going to, right now, we just want to work on these guys, these letters. I'm not going to share the code because I'm not done with it yet, but here is what I have here. I'm not going to hit the share button, but I will drop it in chat. And for those of you on Discord, here you go. Let's take a few minutes to work on that. All right, like I said, don't want to overthink this one. So for each of the letters, we can do a count. If Roman dot count. We can also manually count it using another for loop, but if Roman dot count letter is greater than or equal to 4, or you can just write greater than 3, right? If we have more than 3 of those letters, return false, because that is not cool. That's not, it's not good. Make sense? Right? We can't have more than 3 repeats of those. Now this validation function won't be perfect because let's see. Yeah, no, this will work fine because there's, yeah, that'll work fine. And then finally, let's see, for letter in, we can do the same thing here for letter in the 5 values. So 5, 50, 500. If that is greater than 1, right? If we have more than one of those, right? We're not allowed to have the 5 values, right? Return false. Make sense? Shouldn't it be that there's no more than 3 in a row? Yes, we could. So we're going to try that out. If we wanted to make sure that there were no more than 3 in a row and just be sure about that. Right now, the way I'm kind of doing this is ensuring that, because you can only have 3 in a row. Because if you go 1, 2, 3, if you go to 4, it's going to become IV, right? And then it will be VI. And so there's not going to be an opportunity for another I to be in front, is the point. So we could check by iterating through and making sure that a slice contained no repeats, but we don't need to. And then otherwise, we'll just return true at the end. And again, for validating stuff, assume that it works until you find a way to, until you find something that breaks it. So now we have to ensure that writing numerals that decrease from values left to right represents addition, right? So right here, we're going to go ahead and write our convert function, def convert. And what we're going to do is we're going to take in a Roman numeral and we are going to convert it to Arabic. Arabic is equal to 0. Return Arabic at the end. Okay. So we need to convert from Arabic to Roman, which is what you're going to work on next. Now, how in the world do we do that? So the first step is kind of the naive one, which is what we're going to do is that we're going to iterate through every letter in this. Okay, every letter in the Roman numeral, every number in the Roman numeral, and then translate that letter using the dictionary. Translate it to its Arabic value and add it to the Arabic total. Make sense? But what about this other case, the negation rule? We'll have to get it. We'll have to check that. We will burn that bridge when we get to it next. But for right now, just assume that everything is going to be perfectly in order, that there's no negation rule currently. So assume that you're going to get MCM, like you're not going to deal with with these values. Right now, it's okay to translate MCI this as 1,100, 2,100, 2,101, 2,106, which is not correct, but that's the first step, right? Which is just adding up all the values. Does that make sense? Once we add up all the values, then we can worry about how to handle the negation rule. Make sense? So let's just work on simply adding all them up. So take a couple minutes to do that one. And then we will complete that, and then I'll complete that, and then we'll start thinking about, okay, now what do I have to do? People want more time on this one? Okay. Mhm. Is there a what? Del.
So that like I can tell you like what term I want to do.
Yep. DL and then.
Because I remember like the first contract, the first value was wait.
Yep. Yeah. What are you? What's the context for this?
I think this is just command I have this right yesterday. I didn't I hard coded to move it. I realized I didn't need to do it, but
Yeah.
Well,
But
first
for
number.
number. And what is num list? Oh, num list is that okay? But here you need you're looking it up in the dictionary. You're not converting it into this.
Trying to work through the term.
Oh, but in that case, you want to slice. So when you read your file into a string.
Alright, so that's the thing. Like I don't want the second thing on.
Yeah. So like a text. Assuming it's a list, okay, a list of strings. Text is equal to text. And then 1 to the end.
Yeah.
But if you're just directly doing the for loop on the file, that won't work. You have to read lines.
Okay, so I
Use, called read.
sounds like the hurricane track. I just decided to like remove just man. So that's how I do it.
All right. So let's go ahead and do this portion. So now this is fairly straightforward for this first part, which is how do we convert them? Which is for numeral in our Roman numeral, in our Roman number. So for each of those numerals, for each of those letters in our Roman number, what are we going to do? We are going to translate it to its Arabic value. Call it real value is equal to RTA. We can call it Arabic value, and then I'm going to call it Arabic total. over here. Yeah. And then Arabic total is equal to Arabic value total plus Arabic value. And what I did here, and I could have just made this one line in here, but I figured I'd split it up saying, okay, translate it into the value and add that value to our total. Do this for every one of our letters. Right, does that make sense? So if I convert, so if I print convert BIII, this should give us 8. And if I, which it does, and if I do MC, that would be 1,108, right? And the reason is that basically what we're doing is we're passing in the string. It goes to the dictionary up here and says, aha, you're asking me what M is. That's 1,000. Let's give you 1,000 back. And we're going to add it over here. Okay, 1 second. Gonna look at 1,000 and give you 1,000. Then we are going. Then I say. Then it looks and signs the C, translates it to 100. Then it looks at the 5 and the V and translates to 5. And then it for each of the ones, it looks at the 1 and translates to 1. Each time it translates it, it stores it in an Arabic value and adds that to and increments Arabic total by that much. Now, however, we're doing 1,108. What if about 1,109? And we'll see that if we run that, we're going to get 1111, because currently all we are doing is adding, right? We're currently adding to make sure that it is in order. Sorry, we're just adding the numbers kind of blindly. But we have this negation rule where if you have a value that is less, that if you have a value, if the value to the left is less than the value to the right, in other words, if it's not in order, then that value is a negative value, right? So instead of doing, so this is, sorry, let me simplify a bit. This is 11, 10, and then 1 after that. But this is 9. It's 1 before 10. Make sense? So how do we go through that? Well, you have to look ahead. So that means that, and the only way we can look ahead when we're iterating through a list or a string is to use indexes, right? We have to use indexes in some manner. So there's a couple ways we can do that. To get our index. The first way to do this is, of course, to just simply go and say for number in range Roman. So for index in range length of Roman, that's one way to do it. And then say number is equal to, say numeral, which is the value we had, is equal to Roman index, right? Get the index of that Roman numeral. Or give me the numeral that's at the index of this Roman number. And you'll see that basically we get the same value. It comes out as 11 because we're not using it yet. But now that we have a index, we can check what's to the right. Index plus 1, or rather I should say Roman index plus 1, because some of you still take things a bit literally, would give us the value to the right of where we currently are. Likewise, -1 would give you the value to your left, but really we're looking at the right. And basically we're asking if we're less than the value to the right of us, then we should, then this number should be negative. Now, there is one issue though, which is that what about the last number? What about the last number? The last number, so basically, what I do is I say, look at I, look to the one to the right, I see an X, I'm less than this, so I'm a -1. So I should subtract rather than add. Then I'm at X, I'm going to compare it to the value to the right of it, index +1, but there is no index +1, right? That would give me a null point, that would give me an index out of bounds exception, right? An index out of bounds error. Say, hey, that's not a valid index. So there's the way we get around that is by not handling that one inside the loop. We can just simply go up to, but not include the last one. Right? We can do that by slicing, or we could say go up to, or we can say length -1 so that we leave that last digit out. And then we can add, that last digit in, because that last digit is always going to be positive because there's nothing to the right of it. That's basically, we can handle it there. Or so we can handle it either by subtracting from the range or by doing a slice. Okay. Now, personally, I like doing the slice because I prefer to do when I deal with indexes, I like to work like this, which is that I like to, instead of doing length and Roman, which is how you would do it in a lot of other languages, or range and length, I like to do enumerate. Right? And if you remember, enumerate gives me two variables to work with. It will give me the index and then the value at that index. So index and numeral, it gives me both of them, right? It gives me both of them. And I like being able to work with both of them. And then, so if I wanted to slice, I'd say, give me a copy of Roman, but everything but that last value. Right? And you can tell that I've gotten very comfortable with using slices in the negative indexes here. Everything but the last value. Up to, but don't include this. Another way of writing that is that, and that's shorthand for length of Roman -1, right? Right. So remember what this is, what the slice is. The slice is if I leave out the preceding value, that's shorthand for 0. And then I'd like to go up to, but not include this index. And this means I'd like to include all of it. And so leaving it blank is the same as leaving it as this, which is a bit of repetitive. Roman, and then inside the Roman call, the index call for Roman, you have a Roman inside, which makes it it's like a Matryoshka Roman doll, I guess, or something like that, which makes it very kind of confusing. So hence why we can use this -1 to kind of say that's the same as length of the thing -1. So this goes up to everything. And remember, -1 is the last one. And what we'll do is that we have an easy check here. If I say easy, but it's not. If I say easy, but working through all these exceptions can be a bit tricky. So if numeral is less than Roman index +1, we want, let's see. And what we want to do is, there's a couple different ways we can do this. We could do an if else block. So one way we can do this is just use some math. We can say modifier is equal to 1. And then if it's less than, if it should be negative, we'll say the modifier is equal to -1 instead. And then what we'll do is that we will multiply our the Arabic value by the modifier. So if it's correct in the correct order, we multiply by 1, which is the same as doing nothing, right? But if it's in the incorrect order, right, if the value to the right is bigger, then it's like if we have a 1 before a 10, then we want 1 before 10, which means subtracting 1. So we'll multiply by -1. So that's one way to do. Okay, one way to do that. And right now it's giving me -1 because I don't add in the last digit at the moment. So we'll do that. So we'll do that right now before we forget it. So Arabic total is equal to Arabic total plus the last plus RT Roman 2 Arabic for the last Roman, last thing in Roman. Okay, and now run it. So there we go. So that's one way we can convert it to negative. The other way we can do this is to not use math, because a lot of you are basically saying, hey, I don't want to use math, but I don't want to, and that's perfectly fine. And in that case, what we'll do is we'll just use a logic statement. If it's less than, what we'll do is we'll do it like this. We'll get our value. If it's less than the thing, and if that value is less than the value to the left of us, we will subtract it. Else, we'll add it. Make sense? So this is another equally valid way to do this. Rather than using a negative number, what we're going to say is we get this Arabic value because we're going to use it regardless. And honestly, I could just do this over here. I could just repeat myself. That's perfectly fine as well. There's nothing wrong with doing this either. Basically saying, hey, if the number is less than the number to the right, then I want to get the value and subtract it. Otherwise, I want to get the value and add it. Make sense? Both ways all these ways I've showed you are all different and equally correct ways of solving the problem. And that's the ones you want to, and the way you want to do it is the one that makes sense to you. You know, I'm coming from a very heavy math background, so you know, multiplying by -1 to subtract makes perfect sense to me in my addled, in my crazed and addled math overdose brain. All right. But it may not make sense to you, and it's okay. It's perfectly valid to use a logical statement instead. All right, so of course, if we go one way, we want to go the other way, okay? So can you write a program that goes in the opposite? Oh, and let me hit the share code button, so now that you'll have an answer for this. Okay, there you go, share code, shared with everybody. All right, so now can we convert from Arabic to Roman? And there's a bit over here that I'll go into in a minute with the ordered dictionary, but I will cover that in a second. That's not any different. So our objective now is to go the other way. Let's write a program that goes in the opposite direction. And I actually find this one a bit easier to do, okay? So given an Arabic numeral, we want to convert it into the Roman counterpart. And again, I find this easier because it works the same way. So currently in Python, in the current versions of Python, which is 3.6 or later, right? As we saw when we add stuff to a dictionary, so one of the key factors about dictionaries and maps and hash tables is that we are making some sacrifices. That we make some sacrifices for them to be A, versatile, and B, extremely fast. If you take 2168 which is the other class I teach, which is data structures, you'll find that that dictionaries work in constant time, meaning it doesn't matter how many key value pairings you have. You can just retrieve it as fast as anything. Doesn't matter how big it is, it takes the same thing to find. But we do so with a sacrifice. The sacrifices are two. The first is that we make no, first is that we just sacrifice memory and space. We sacrifice RAM to the gods of runtime, essentially, to make sure that these things run faster. Okay, the second thing we do is that you normally can't assume any order about the way these work, unless it's explicit about this. And in Python 3.6, it did get explicit with the order, and by which I mean the order the keys are stored in. And the orders the keys that are stored in is the order they're inserted in. It will, if you iterate through your dictionary, then it will give you the keys in the order they were inserted. This used to not necessarily be true. And in other languages, if you do that, you may get a different answer. So just remember about those kind of assumptions. But that's the reason now, but that's for like current versions of Python. The browser uses Python 3, but it uses something that is a later version, sorry, that early version. So just so that it would run in the browser. And so it's using something called an ordered dictionary, which has that same behavior. So an ordered dictionary works just like our dictionary, but it's just what they have to do in the browser to get it to work in the browser. Make sense? Okay. So as we can see here, we've got a Roman dictionary, which converts Arabic to Roman. And we see that they've got, it's the opposite of how it goes. We've got 1,000 for M, 900 for CM, 500 for D, 400 for CD, one before. So basically we're doing all the exceptions, right? And then 100, and then so on and so forth. So we want to complete, so let's go ahead and fill the rest of these out. So what's the next key that we should put in here? What's the next key? This first number. What's the next Arabic value we should translate?
50.
Not 50, 90, and then 50. And then 50. So 90 is 10 before 100, right? So it should be XC, 10 before 100. And then 50 is L. And then 40, yeah, it's not necessarily intuitive the first time we see it, but I'm hearing from students, oh yeah, XL, 40 is extra large. And now, so we're not doing like 40, 30, because 30 is just 10, 30 is just 3 L's. So there's no need for that. We're basically writing down our digits and the exceptions, the weird things. So 10 is that, and then we need 9, which is 1 before 10, right? So 9 is 1 before 10. And now that is 5. And then we have 5 is our next one. 5 is V. And now we need 4, which is 1. So 4. 4 is 1 before 5, right? And then that's it. Just remember to put commas after all these things. And then we have our fill in the missing entries. Okay. And then we have this, and we filled it in. All right. So now it's asking us like, okay, here's your dictionary. No more directions. Have fun. Translate it to Arabic to Roman. How in the world do we do that? Okay. And just FYI, when I did interview at Google, by the way, this was a question that got asked to me. I can't remember which way, but it was one of the ways. It was one of the things I got asked, which was translate Roman to Arabic or Arabic to Roman. Can't remember which one. So, you know. So what do we need to do here? Well, we're going to take in a value from our user. We're just going to skip the part where we take in a value from the user and we're just going to test it on our values. So let's just go ahead and skip to a convert function where we're going to take in a number, right? Def convert an Arabic number. I'll just call it Arabic for consistency's sake. And then we'll take a Roman, and this key is called Roman, so I can't just call it Roman. So Roman, or yeah, Roman. Let's just call it output is equal to that, right? We'll just call it our output is equal to an empty string because remember, Roman digits are strings, Roman numerals are strings. And then when we're done, we're going to return our output. So how do we convert this? Well, the answer is rather than doing a for loop and going through each digit, what we're going to do is we're going to use a while loop. We're going to use a while loop and basically say, while Arabic is greater than 0. And here's what we're going to do, and then I'll give you a bit of time to work on this before I show you how to do it. What you're going to do is that you want to iterate through each of the keys here. So for key in Roman, right? And basically say, hey, is this value smaller than? You basically want to go, actually, we don't necessarily need this while loop out here. Just need, yeah, we just need a for loop with a while loop inside of it. That's the issue. So for each of these keys, you want to ask yourself, hey, is this number smaller than this number smaller than the Arabic number I'm trying to translate? And if it is, that means I can subtract it. So what I'll do is I will subtract out. So like if I'm trying to convert like 4,000, sorry, not 4,000, but like 2,000, 2001, here's how it would work. I'd say, hey, is 2,000 bigger than 1,000? Yes, it is. So let's go ahead, subtract out 1,000 and print out an M. Okay, so here's what I've got. I've got 2001. Let's actually give us a good example. 2034. Let's go ahead and do that as a good example. So what we're going to do is we're going to iterate through this. Is 1,000 less than 2034? Yes, it is. So what I'm going to do is I'm going to subtract 1,000 and output an M. Okay. Is 1,000 greater than, is 1,034 greater than 1,000? Yes, it is. So I'm going to subtract 1,000 and output an M. Is 34 greater than 1,000? No. Okay, let me go on to the next one. Is 34 greater than 100? So 900, no. Is 34 greater than 500? No. So I'll go to the next one. Is 34 greater than 400? No. What about 100? No. 90? No. 50? No. 40? No. Is 34 greater than 10? Yes, it is. Is 24 greater than 10? Or equal to? Yes, it is. Is 14 greater than or equal to 10? Yes, it is. Is 4 greater than or equal to 10? No, it's not. Okay. And then is 4 greater than or equal to 5? No. Is 4 greater than or equal to 4? Yes, it is. So subtract 4 from this, output this. Is 0 greater than or equal to 4? No. Why did we start with 2034? That was my example number. That's just what I chose. So just to show you how this algorithm works, which is that you look at each thing and basically ask, can I keep subtracting this value? So that's a for loop with a while loop inside it. Okay, so go ahead and take about 7-10 minutes to try to work on that. And then I'll show you, and then I'll put that algorithm into code for you. And then we'll be done. All right. So so what we've got here is we've got our Roman dictionary. So for value, for number in Roman. So that's our key here. We just go ahead and test that. Print num, always a good idea to do that. And then convert 50. Oh, right, it's not F5, it is history. Boo. Oh, that's a pain. I hit refresh rather than doing that. Okay, I guess I'm gonna have to do this at super speed. 90 cm. 50 L. 40. Thank you. There we go. All right. Def convert. So let's go ahead for num in Roman. It was just a hotkey for instinct. Num. So I hit F5, but in the browser, of course, it's refresh. So there we go. That works exactly as I want it to. So def convert from Roman, or sorry, def convert Arabic. I want to take an Arabic number and we want to convert it to Roman. So output is equal to blank, return our output so I don't forget about it. And now what we're going to do is for num in our Roman converter, while Arabic, well, our Arabic number is greater than or equal to this number, then we will say Arabic minus is equal to Arabic minus the number. So we'll subtract it out, right? So, right, if 3,200 or something is greater than 1,000, then we'll subtract out 1,000 and we'll add the respective Roman letter to the output. Output plus equals Roman for that, the Roman numeral for that number. Or we'll just simply say, or we can just simply break that up and say, hey, Roman numeral is equal to this. Output is equal to output plus Roman numeral. And output and print so now print convert 300, let's go with 327, which should be CCC XX VII. And let's go ahead and do 694. 694. That gives us D C. So what is D? D is, sorry? Oh yes, 500. So D, yeah, 500, 100. So it gives us 600. Then 900, then XC, 10 before 100, and 1 before 5, which is 4. So surprisingly simple. So let me go ahead and share this code. And so there's an additional challenge here if you want to try it on your own, to make things, you know, to make things more, you know, better at converting, but obviously not enough time, and you can only, and after after an hour of Roman numerals, I'm sure you're sick of them as well. So now with regards to the Hawaiian pronunciation homework, right, and dictionaries, right, the idea here is that with the dictionary, you can convert from, you can have dictionary stores that will convert like either a letter to the pronunciation of that letter, or two letters to the pronunciation of that letter pair, right? Like EI for A, right? Converting EI into the A syllable. So just keep that in mind. Have your TAs gone over the the Hawaiian pronunciation in lab? All right, so it's possible to do it without dictionaries, but dictionaries also mean that you don't have to deal with like 50 different if statements, you know, one if statement for each possible syllable it is. So I find that one to be particularly fun. One thing, and when we go over, we will be going over the, so I will talk maybe about that one a bit more on Thursday, but more importantly, I'll also start the pig homework on Thursday as well, because the pig homework, as you'll see, is a multi-part homework, and we're going to look at that as part of our exploration of what Monte Carlo approximations are. So for that, by the way, we note that there isn't any textbook readings for Monte Carlo approximations, okay? So for Thursday's lecture, and please just bear with me for just a bit longer. For Thursday's lecture, please go to Module 9, and rather, I want you, for Monte Carlo approximations, I want you to learn about the Monty Hall problem, okay, which is a mathematical paradox, or rather, it's kind of a paradox because it's unintuitive. This video of what a Monte Carlo simulation actually is with physics, and then this thing about carnival scams, you know, those games that you at carnivals, right? This has some and the reason I bring this one up is that it's very amusing, you know, seeing these games and seeing what their gimmick is. But the way that the guy who did this video, the way he figures out the actual odds for these games is that you can't calculate the odds of that somebody's going to throw a ball into a basket, right, or a ring around something. You just don't know that. So what you do is you watch the outcomes. You literally watch people and see, okay, how many people played and how many people won. That's a Monte Carlo approximation. That's a Monte Carlo method. Basically, it's figuring out statistics via observation. In other words, it's saying math is hard, but counting wins, losses is easy. So that's all we're going to do. And so we're going to see how we can do hard math by just simulating stuff. So be sure to watch these videos. These videos are fun. This last one's the most fun of all. So just watch those before we do that. And then there's a article that I would like you to glance at if you can, which is about Monte Carlo simulations. And if you can read it, great. And if you can't, or if it's annoying, understandable. And what we'll do is that we will talk about that as well as a bit about some other stuff on Thursday and more on it on Tuesday. Okay. All right. Class is dismissed. Okay. Yes. How can I help you? And hold on, let me stop sharing and